talk about this, I've done a little work with them. It is going to be really easy. So, come on ahead. Lock it up.
Can you hear me now?
Yeah.
All right, good morning, and it's actually good night here still for me. It's going to be tough, right, for me, and hopefully enjoyable for you. I'm going to make it as funny as possible because the content really sucks. That's how we do it.
WebSockets are not pretty.
Yeah. This is the only slide I have. So basically, I'm going to present the work that we did with a couple of my colleagues at Qualys during the summer, and it's all about WebSockets. And what are the WebSockets? WebSockets are part of HTML5, and this is a new, cool way of communicating. New way of communication between server and client. Prior to WebSockets invention or creation, there were few workarounds that people were using, mostly using long polls or homegrown stuff like Socket.js or WebSocket.js. And in addition to those, there were newer technologies in HTML5 like server-sent events, but that one is only giving you one-way communication. So, what is WebSockets? WebSockets are part of HTML5. They are used for two-way, bidirectional, real-time communications between server and a client being your web browser, and is described in RFC 6455. So I'm going to distract you for a second from the slides and just set up few things. If at any time you have questions, please ask, because it's going to be very boring for you to listen to me for babbling about some nonsense forever. And also it will make my speech clearer if you ask me questions, because if you ask those questions later on, I'll forget the content, because I'm really sleepy and this doesn't help, and this looks like it's the driest cone ever. I couldn't find beer anywhere. So what's WebSockets? WebSockets is two parts. One part is the definition of the protocol that server should implement. And the second part is JavaScript API, very simple, with functions like send, that basically sends over JavaScript strings or array buffers and binary data in a block. To establish WebSocket communication, there is a regular HTTP handshake going on. Oh, it's loud now. Sounds good. So, to start off WebSockets, we as in a web client starts off a regular HTTP request, and the beauty of that is that it will go through all the proxies and all the infrastructure that your regular HTTP traffic will go. After the handshake, it will be upgraded to more thing more like raw socket. But before the upgrade stage, it is communicating through regular HTTP. So first stage of handshake would be client sending a few things like the version it implemented, the version of the WebSocket implemented, the origin, which can be useful for security purposes, and sec WebSocket key, which is just a pseudo-random number, which is going to be appended and hashed and sent back. So basically, this is response from the server. Server would send you a connection upgrade header, and then base 64, SHA1 of the challenge pseudo-random number plus a unique UID. And that's not done for any security purposes, it's just to establish that both client and server are talking WebSocket. So, as I mentioned, this handshake is mostly to establish that we are talking WebSocket, and then there are a few good things that are in a spec. One of them is you cannot establish a plaintext WebSocket connection, which is WS column, from secure HTTPS connection. So basically, if you have a website that has a secure web page delivered to a client, from that resource you cannot establish an unsecure connection. That's good because you can't really mix, intentionally or unintentionally mix secure and unsecure content. Also, it has origin header, and using that, few of the CSRF attacks could be mitigated. And here is the basically data frame. I won't go into details, but there are a few interesting fields like the mask bit, and then if mask bit is set, there will be a mask. We'll talk about it later. And another interesting aspect of data frame is that the length field itself is of a variable length, which means you could specify a length of same value in a couple of different ways, which gives you, as an attacker, or not as an attacker, but a person who wants to establish a covered channel, gives you some entropy to play with. Let's talk about masking. Masking is basically XORing the whole data frame with a key that is also sent with the data frame. No security reasons here. The only reason for masking was historical. Some of the proxies and intermediate devices on the network got confused by data frames, WebSocket data frames, and they were trying to be smart and reading the data content of the data frame, and that was causing all kinds of problems. So now masking was added, and none of those intermediate devices can understand what is in it. It's all garbage for them. And actually that's a problem now, because security devices like firewalls, IDSs, IPSs, don't know what is being transferred through WebSockets. And that plus the entropy with length, also the mask value itself can be an entropy, poses a danger for those who are trying to figure out what kind of traffic their organization is having with outside world. So there are a few things that different providers of WebSocket implementation, WebSocket server implementation can play with. Some of them are doing great job, some of them not so much, as we will see further on in the talk. So one of the issues would be not to give out too much verbosity when you are in the middle of establishing a connection, or if there are some error conditions. Data frame security, basically the data frame itself doesn't have any security embedded in it, unless we talk about the transport, because for WS there is also WSS, which is secure WebSocket, but other than the tunneling itself, there's nothing else extra added. Few things come free, like origin header or CSP directives. Some of the CSP directives can affect WebSocket security, but other than that, the protocol itself, data frame, doesn't have anything added to it as far as security is concerned. Let's see what is the use of WebSockets in a real life. So for technology that was waited for many, many years, and people were trying to simulate what WebSocket does now with hacks like long poles and flash WebSocket based stuff. Looks like there is no significant number of users of this technology yet. There are a few cool little applications here and there, like these embedded devices. There is an implementation of WebSocket for a PIC-based microcontroller that you could basically run on a simple $2 chip and have your web browser communicate to it. That's just a play toy. Implementation-wise, looks like everything is all right. There are 3 major JavaScript libraries that have WebSocket support. Almost all the programming languages, major programming languages, support it, and here is the list of all the WebSocket server implementations. WebSockets are cool in a way. You can have very fast full duplex communication, but when it comes to user capacity, it doesn't add anything. It's still limited to the same old problems of HTTP. It's per connection, it's connection number limit that it basically is limited to. And if your web application doesn't really need full duplex and real-time stuff, if it's not an online game, you probably don't need WebSockets. Because with WebSockets, you have one user or one connection to one WebSocket, one-to-one relation, and which is much more wasteful than regular HTTP-based, stateless web application, or even stateful, where the connection pool would be shared among many users. Performance-wise, there are good news. Because of its very low overhead in the header part, continuously sending many little updates from server to client or client to server would be much faster with WebSockets, because if it would be done with older way of using XHRs and long calls, each request would be a full-blown HTTP request. As with WebSockets, this is only like a raw socket, and only few bytes going in and out could cover the header part. So let's see how it's been adopted in a real life of applications. We run a bot that, not a bot, a robot, mostly a crawler that went through Alexa top 1 million, but it didn't finish 1 million. It ran through 600K top websites and was trying to determine if any of those websites use WebSockets in their main page. Very few numbers, it's like less than 1%. Actually, it's 0.15% of the sites are using WebSockets on their landing page, and most of them, majority of them, 95% of them are connecting to the same server anyways. So if you take all of that out, it's only a handful of number of websites that really have WebSockets as a way of transport for any reason on their website, except the customer support case that was 95% of all the existing installations of WebSockets, sort of. And that's just very, very low number. And one can wonder why it's the case. We think that's because there are no tools. There is no proper security or scalability research yet. And honestly, trying to set up WSS is painful as setting up any HTTPS server. It's even more painful. And people are just afraid of new things, maybe. So, how I'm doing so far, guys? Any sleepers in a row? I thought it's gonna be easy for me because English is not my first language, so we can relate to that with majority of the people here. So, but my accent is probably very terrible, and you don't understand half of what I'm saying, but that's fine. So we're going to have a little demo here. So basically what I'm going to demo is a browser exploitation toolkit or framework that we wrote that is not going to be great or replace beef or anything like that. But the main purpose of demoing this or writing it was proof of concept of having pure WebSocket-based communication between victimized browser and command and control center. And one benefit of it is that if you do that now, you're guaranteed that none of the IDSs or firewalls will catch you. None of those security devices knows how to parse WebSocket. I mean, they know how to parse it, probably. It's not that hard, but none of them really does. None of them really care. So if you are a bad guy right now and you want to talk to your victim, remote victim, talk to him using WebSocket. So what we have here, on the left side, we have our application called Waldo that I've just started. And it's running WebSockets with WebSocket server that is implemented using a C++ library called Socket PP. And then I have a very good website here on the right side. It's very powerful and useful, but it's been hacked and somebody did man in the middle to it and injected a piece of JavaScript. So now whatever this guy on the left wants to do with that browser, basically that browser tab, is possible. One thing that is possible is to get the HTML of it. That's not a biggie. We could also initiate keylogger on that remote machine, and then let's see if it captures my password. Oh, that's good. Okay, so here's the response from a victim. My username Vaagn and my password won't tell. That worked. We can do all kinds of crazy stuff with that compromised client. We can crash it. We can use it as a bot to those other servers using WebSockets again. So imagine there are other crazy guys somewhere that decided they're gonna implement WebSocket server. And our client here can open up to 1,000 connections to that server and basically kill it. Our client won't die, but that server will definitely die. I mean, not definitely, depending on implementation of the server. So we will close this down, and just to show what was injected to that client was this piece of JavaScript. It's not much, it's just a few things that it does. Basically very straightforward. These are the WebSocket calls. No magic, nowhere. Everything is pure JavaScript. All right, back to the slides. So let's see what are the secure. So we went through some introductions. Now we know what WebSockets is. Now I know what WebSockets is. And then let's look at the problems that there are with WebSockets. So basically WebSockets is not solving any security problems. It's not designed for that. And if anything, it may add some to it, like things like we already discussed. It it is very easy to establish a covered channel through WebSockets. Because of the masking, nothing is readable for now for firewalls and IPSs and IDSs. Plus, there are other things that add to it. So, one thing would be anything that is web. If you can sniff HTTP, you can sniff WS. Basically, WS is the WebSocket counterpart of HTTP. If you can intercept or inject, you can overtake WS or WSS. So it means if you can do man in the middle, you can also spoof the WSS connection. So same story with HTTPS, HTTP. If you didn't start with HTTPS, then you will be downgraded to HTTP somewhere in the middle. RFC defines a good rule that you cannot really mix unsecure WebSockets with secure HTTP connection. You basically, if you're starting with HTTPS, you cannot establish unsecure WebSocket connection, WS connection. You should have WSS. It's really good, but none of the WebKit-based browsers implement that yet. So, few worrisome things here. Denial of service is really real. Many browsers have many different limitations on number of connections, but most of them allow you to go over hundreds of connections per resource, which is useless probably and not that smart. So you can basically have a malicious website that just hangs the client. It's not that sexy, but it's killing your browser anyway. Denial of service on a server side is more real and more dangerous. And there are, as we know, there are tools like slow lorries, slow HTTP read, that are trying to establish persistent connection with HTTP server in order to drain the resources. And they are not only establishing connections, they are striving to keep those connections alive. In the case of WebSockets, it's not necessary to do anything extra. The connection is alive and online all the time. So you're basically, if you connect to a web server, not web servers, but WebSocket servers, a WebSocket server from a client, you drained one element of the connection pool right there, and it's not going to be released until you close that socket. So you can, from a single client, you can open thousands of connections. And if the server implementation is not really great and scalable, which unlikely all of them will be, you are likely to drain socket resources really quickly. So, well, what's the case with browsers? All the browsers now are WebSocket compatible. I jumped into Vaagn late last year. Now it's complete, all the browsers are there. Few nuances with different browsers. Message sizes can be, acceptable message sizes can be as big as 2 gigs. Like, I don't think which one wasn't. I think Opera would accept 2 gigabyte data where you could basically open a connection, tell the server that if your browser, being Opera, connects to the server and that server says, I'm gonna send you back 2 gigs of data, your browser is gonna accept that 2 gig data, and maybe server won't send you that 2 gig data, and you will have 3 tabs like that, and maybe you're allocating 2 gigs for each, and then you drain your RAM in 2 seconds. So basically, few quirks like that. Message size is not well established. Mixed content handling, as I told you before, WebSocket. So basically, HTTP cannot open. HTTPS cannot downgrade to WS kind of policy. It's not implemented for WebKit browsers. WebKit-based browsers. Also, there is maybe a flaw in Firefox, maybe not a flaw, maybe a security feature by design that web workers cannot create WebSockets. And that's probably a good thing, because then you would have a multi-threaded, multi-WebSocket attacking client of some kind. So coming back to security issues with WebSockets, I would like to reiterate the fact that the masking of data frame content is really a big problem for detection. DLPs, firewalls, IPS, IDS, they won't see the traffic. Nobody. And we talked to a couple of vendors. We challenged a couple of them to basically answer the question if they are looking at the WebSocket data. Nobody does and nobody cares. And that's one of the bad things about all WebSocket adoption. If security devices won't adopt it, you won't work with it, then end users will be scared of it, and developers will be scared to implement WebSocket solutions. So masking is one problem. Also, there are a few things like missing auxiliary data, like data types, content type is not there. Few checks in few firewalls are based on those fields, those headers. Those headers don't exist here. It's not your standard HTTP traffic. And as we mentioned before, covered channels are possible. Establishing covered channels is possible because of the same masking and entropy in length field. Also, the mask value itself can be part of entropy. So I think all of us here are for security here, right? In a room, yeah? No, nobody for security? I mean, you guys don't care about security? I don't either. Let's go drink some rum. Anyways, but if you were in a security, which you probably are, but just too sleepy to acknowledge, what you would like to do with WebSockets? You would like to be able to inspect it, the WebSocket traffic. You would like to have ways to play with it. Let's see what you can do now with all the tools that are there. Few good adoptions by industry-leading tools. Wireshark can dissect WebSocket traffic, will nicely give you all the breakdown. Fiddler does the same in read-only kind of manner. And that's probably it, unless you count OWASP proxy that has some kind of WebSocket support. I'm not sure which level it is right now. So we did some of our own stuff. We played with our homegrown tools. So what can be done? It's really easy to do fuzzing of WebSocket traffic on the client side, because you can really just take the WebSocket JavaScript object and inherit from it and override the hell out of it, and then you can do whatever you want. That's one thing that we did. We also did try to fuzz some of the WebSocket server implementations. So this is what a JavaScript override would be, to be able to do whatever you want with WebSocket traffic on a client side. And with frameworks, different implementations of WebSocket servers, we were trying to get some crashes and get some bounty money, no luck yet. But fingerprinting works, that's the good news. So basically, if you look at this, few slides here are the handshake responses from different servers in normal operation and with some failure scenarios added. And few servers give out their names in even regular handshake, so you can fingerprint those. There is one very good implementation of WebSocket server in Node.js that doesn't give out you any additional information, so you cannot figure out what kind of server it is. But if you push a bit of garbage to it, it will give you specific error message that you can then relate to specific version of Node.js. So we have another demo. It's basically the same demo. I have a lot of time, so I'm gonna just demo the same thing second time. You guys won't even notice because you're all asleep. So in reality, it's the same application, but we're gonna just see how easy it is to fuzz WebSocket traffic using just console, debug console in a browser. So what we have here, let's see let's imagine this wasn't this hacking application and it's regular traffic going back and forth from a client to a server and server to a client. So the server would ask for something and then client would give that something back. Now imagine that we want to intercept it or fuzz it or try to figure out if we can inject something to the server. Let's do this. So what will happen now, whatever the client sends back will be appended with that string. And if on the other end on the other end, the server would take it directly to SQL, let's say, then we could inject SQL here. Or if we want to not append to it, but replace, we could do something like that, and it doesn't work. Replace with garbage. And this guy asks for, I think, cookies, and gets garbage. Stuff like that, not so smart, but way too cute. Right, so what can we do with WebSockets to make them more secure, or how can we use them to not to get owned all the time? First, we need to understand where to use them. It's not a panacea. It's not for every single web application. We shouldn't replace everything and anything with WebSocket. So it's good for time-critical, full duplex applications that really, really strive for interactivity. For anything else, it doesn't really make sense. Like if you are trying to use your regular web server, if you're trying to replace your regular website with something with WebSocket-based application, unless there are very, very big reasons, you probably shouldn't. And we also need to remember again and again that it's not solving problems, it may add problems. So before we start to implement WebSocket-based web application, we need to understand if the capacity can be an issue here. So again, the number of connections per client is 1 or more. With regular HTTP, it's used shared pool, so there'll be a problem there. But if you are to implement some kind of WebSocket-based server, an application, few things can be taken into consideration, like origin header that comes with Handshake can be stored and used to counter CSRF attacks, for example. None of the server implementations should assume that client is web browser, because even if it is a web browser, as we showed, a good web browser wouldn't append SQL injections to it. I mean, good JavaScript application, but JavaScript is very changeable, so don't trust the client. Even if it's web browser, it can be abused. Use WSS wherever it's possible. It's basically a no-brainer. And use this new cool feature of CSP, a directive called Connect SRC, which would limit your client's connection to specific WebSockets.
Wouldn't that be possible to implement on the server side also?
Which part?
The limit on connections to each client, for each client. Is there a way for the server to identify each client uniquely so it only allows having one connection per client or something?
There is no right answer here. It's basically, there is nothing built in like that. So each person, each developer is gonna go and reinvent his own build. And that's one of the problems. Because what WebSocket gives you, except the security feature called WSS, which is just a tunnel. It's just something like raw socket connection. Then you gotta figure out what is the session, who is the client. You need to figure out what's the token for you, how you're gonna pass that token from HTTP or HTTPS authentication to this WebSocket layer. So a whole bunch of problems that will arise from mixing two different domains or worlds, HTTP and WebSocket, because they are not the same. The initial connection is through HTTP, but then that's it. It's like raw socket. But with CSP Connect SRC, you could tell the legit client that you are not gonna connect to anything else but this. And I mean, as with all the other CSP directives, it helps to mitigate a few of the problems. And the last point on this slide, be careful when implementing the HTTP handshake, means if you are writing your own WebSocket server, you're not reusing standard servers of wide distribution. Be careful, because when you do the handshake, you can have few problems. Like you can be easily fingerprinted. That's the smallest of the problems, and up to the buffer overflows and other issues. So, as we discussed right now, like a minute ago, there is no security in the protocol for things like session IDs and other elements that come from HTTP, cookies, headers that usually work with HTTP may not work here because we are in a different context now. Plus, you can have the good old set of vulnerabilities or problems that would lead to vulnerabilities like buffer overflows, underflows, fragmentation or spoofing of the data, stuff like that. So reiterating through suggestions, WSS means secure transport, not a secure application, meaning you are not guaranteed to be secure if you are in a secure tunnel. You may started it already on a wrong foot, meaning you may created your session with an open text transfer of some kind, and then yes, your WSS connection is secure, but you already are working with a compromised session token or some kind. So authentication and authorization issues, those are issues that are not solved in any way, so you have to have some kind of infrastructure for that. There are no session identifiers. You gotta bring them in from your HTTP world or in any other way. And server side should always be untrustful to the client. And going back to client memory limitations or message size limitations. Some, as I mentioned before, some clients will take more than 2 gigs of data. Now there can be same applying to some of the servers, because protocol really doesn't limit it to, I think it limits to 2 gigs, but basically 2 gigs is good enough for trying to exhaust the resource on the server, if you do it multiple times, especially. So I think we are almost done here, so bear with me another minute when we'll go just through a few more things. WebSockets are new transport tools, or it's a new transport protocol. It's not a security protocol. Remember your old security principles with WebSockets, and also one thing that I would try to reiterate third time probably is that security devices have to understand WebSockets, otherwise it's not going to work. And WebSockets is like port 80. You should be able to see, to understand what's going on with your organization. And that leaves us a few minutes for questions. If you guys have any questions, please ask.
I have a comment.
Sure.
One of the slides said, talked about some browsers using WebKit, but Chrome from Google just announced that they're not going to use WebKit anymore, and Firefox is not using WebKit. They're coding their own engine, rendering engine, I believe since December of last year, to use another rendering engine.
Cool. So
I don't know about WebSockets, if they are going to include it in the Firefox this time.
no, it is in the Firefox. All the existing browsers do have WebSocket support. Support differs from browser to browser. WebKit-based browsers, though, didn't have one of the RFC recommendations implemented, which was mixed content. The thing that wouldn't allow you to establish WS connection from HTTPS. Thank you.
Do you have any recommendations in terms of implementing a server? Because especially I'm a little confused on how to actually provide a mechanism for authentication and authorization. It's kind of all
Yeah, that's a. I think that's the main one single hurdle in a way of embracing the technology, because unless you're just sending some useless information where you don't need authentication authorization, you are stuck with the same problem. How do I connect my authentication system with WebSockets?
There's a provider called Pusher. And they do some sort of, like your server talks to their server, and their server actually pushes to the client, and there's like a dance there, but it's not. I don't think it's pretty secure.
Yeah, you add another layer, then you become less secure. But then from the other side, if you try to implement that yourself, you most probably will fail. Yeah, so the hope was that frameworks like .NET or like some PHP-based tool server implementations would pick up that problem and solve it, but we don't see it yet. Like if you would go and like have turnkey solution where you have HTTP authentication going flawlessly into WebSocket connection, I mean, pushes the token through it and make sure that they are in sync and stuff like that. I don't know of any.
Right. So you wouldn't push a session key through the socket. You know, the HTTP session key, like push it through the socket and validate it with that?
Yeah, you can do that, but there will be other problems before that. And
Yeah, anyone could get a key.
yeah. Thank you. Any more questions? If you don't have questions, I have a question. Which is the best beach on the island?
Flamingo Beach at Culebra. If you have a chance to go there. Yeah, it's an island next to this one.
Oh, island?
A small island, yeah. It's called
Well, it's
Culebra
part of Puerto
Island.
Rico, though.
It's an island municipality.
You
Puerto
go
Rico.
to
It's
Ocean Park.
Ocean Park?
Yeah, you can take a bus to Ocean Park or a taxi. It's really nice.
It's closer. It's easier, more accessible. Yeah.
Take a cab.
Yeah, I have a car.
Oh, well, you
Ocean
get
Park.
there, yeah.
Thank you.